Welcome everyone. We are Hyperflex, and today we are hosting a very exciting session with Mark Vovchuk. He's the senior solution architect from Elastic, and we will get a lot of insights, a lot of conversations. So feel free to keep engaged while we're having this event. The chat will be available for you for any question along the ways, but we will be covering the Q&As toward the end of the session. So please, it would be really great if you could stay until the end. All right, in order to not further ado to the time, let's get started. So for whoever new to us, Hyperflex, we are a IT consulting company, provide the services and offering all the consulting services around Elastics. So we offer consulting services, migration implementations. And we're really glad to have you here. We host webinar like this every month. Yeah, please stay tuned on our website. We are a super proud team. We have a great numbers of certified Elastic engineers. We are covering all the services around search, observabilities, and securities. Yes, that's the dream teams here. We are a global company. We operate from New York, USA, Alberta, Canada, and Pune, India. All right. And now, why people love working with Hyperflex. So we own the Elastic, and that makes us really sharp. We are the expert in the industries. So you don't need to worries about we would have no idea what we do. We definitely have the expert, and all of our engineers have experience working with enterprise level with Fortune 100 companies across industries. So we helping them from building, deploy, support, migrate, or even you just get started with Elastic. All right, and we are very result oriented. We help company reduce by 50% of the cost of infrastructure just by tuning their Elastic Stack correctly. So we're here to help you out throughout the process if you're in the Elastic ecosystem. All right, and here's what's exciting about Hyperflex. We offer some exclusive tools. We have a couple exclusive tools that is exclusively to Hyperflex. So the first one is the Splunk to Elastic migrations. Is the automated tools that help you migrate from Splunk to Elastic. So currently, if you're currently using Splunk and are considering Elastic, then this tool is exactly right tool for you. Yeah, so here, all right, and sorry, I have to go back a little bit. So for this tool, we have an engineer to help you out from start to finish, so you don't have to it puts your system at ease, so you don't have to worry about anything. All right, this is another very exciting tool. It's the Elastic Seamless Upgrade. So if you're an engineer with Elastic, you know that we have Elastic always keep improving the system, having new versions coming out. So we want to make that easy for you. We've created this tool to help you upgrading from one version to another in just one click. We offer pre-check snapshots. Our engineer will be by your side from start to finish. All right. Okay. And today we are really honored to have Mark joining us. Yes. In terms of agenda, we will get started with the speaker introduction. And Mark, I will leave the room for you to introduce yourself. And then we will have the interview sessions where we ask Mark's question. You can share your insights. And we will have some fun rapid fire question sessions. And toward the end, we will cover the Q&As. All right. All right, Mark, I will leave you in for you. The stage is yours.
Sure. Hi, everyone. My name is Mark Vovchuk. I am a solutions architect here at Elastic. That means I am part of our field engineering team, and I get to work with our customers to showcase what Elastic capabilities are, what our solutions can do, and what the platform can do to help optimize use cases and costs and all kinds of benefits of using the Elastic Stack. Before I came to Elastic, I have almost 3 decades worth of experience in the DevOps space, in the SRE space. And I mean, ultimately, I feel like in many cases, I've been a practitioner, I've been a leader, and I'm just really happy to work for a company that has the values that I really support and the tools that make things really accessible to their users. So handing it back.
All right. Thank you so much, Mark. Hi, Vishal. So Vishal is our CTO here at Hyperflex, and he will be in charge of the interview session with Mark today. So, Michelle, I'll pass the mic to you.
All right. Thank you so much. Thank you, Mark. Thank you, Ploy. And I think we are honored to have Mark and talk to us. I guess this was a very detailed introduction. Thank you so much, Mark, about that. And we would love to deep dive into your rich and diverse experience with Elastic.
Okay.
So I have a couple of questions, and I've segregated them based on the depth of working with the scale of Elastic. All right, so let's get started. So
Sure
the
thing.
first thing I really want to understand is like you have worked with so many organizations which are running Elastic at a much bigger scale, all right? So what are the patterns that you consistently see across high performing teams, Elastic stacks which are performing at scale, but their performance top notch? What are the key things that they follow, the best practices that they follow?
So that's a great question. A lot of it's actually going to come down to the thoroughness and understanding of the data and the solution that they're trying to implement. When I see a team that is less successful, it's usually because they are trying to do something that they don't understand, or they're trying to optimize ahead of just getting the details right at the beginning. So it's going to come down to, if you understand the data and the scale, then especially if you reach out to a company like Elastic or possibly Hyperflex or whoever, we can assist you with getting that orchestrated into an infrastructure that meets your needs. A lot of times it comes down to, I need to fit this into that, and that's when things can start to fall apart. And if you're trying to build a scale that is way too large or way too small, oftentimes it's the details that get overlooked because a deadline is looming. So I would say engage early, understand the situation that you're trying to achieve, and you're probably going to be better off in the end result.
Got it. Yeah, it totally makes sense. So to sum up, it would be something like to get to the crux of, what is your use case? What do you want of your Elastic Stack? I guess, yeah, that makes sense.
Yeah, and just
Uh,
understanding your data. Like I said, if it's observability data, you need to just have a general understanding of what you're going to be using it for, as opposed to just collecting it.
got it. Got it. So, so talking about our audience, so most of the folks here know about Elastic in, some sort of degree, some sort of space. What sort of problem do you often find with people who have been using it for, quite a long time? People who have had their clusters for almost 5 or 6 years, and they have been refining it over, each and every step. Now they've refined the basic problems. What are the problems that you see, which, the matured clusters?
So it's a little bit of a diverse answer to that question. And part of this is going to be, if you've been using Elastic for many years, often the biggest thing I see is people who get stuck on an older version, and then they are reluctant to make a change because they have significant investment in the efforts that they've built. And there's a bit of a learning curve sometimes when you're on maybe version 6 or version 7 and version 9 is out and you want to try it. So I would say the thing to avoid there is to not just grab your data, throw it into a new cluster and hope for the best. I think that it comes down to just being kind of regimented and rigorous in your approach to anything infrastructure. Build a pilot use case, do some migrations, do some testing, and understand the differences. So we have a lot of pieces in our release documents that describe either a deprecated API or a change to how something fundamentally works. So don't come in saying, I've been using this for 10 years, I know how it all works. You probably do, but there are probably changes that are significant enough that may make things faster, make things cheaper, and you don't want to just take something from an older version and bring it along.
Got it. I think, yeah, what you have answered is like, a very accurate and very correct information. People get flown away that, I know Elastic in and out, but every version is different, and don't just
Yes,
jump on the versions, do your research. Thank you so
yes,
much.
no
Mhm.
worries.
Yeah. So, and at what time do do most of the teams realize that they've outgrown their original Elastics, architecture or versions, and now they need some sort of modernization effort where they are integrating new features, they're integrating new tools, or just upgrading? What are the points that define, okay, now this is, has run its journey, now it's time to upgrade?
Yeah, I think one of the problems there is that there are some substantial weaknesses when it comes to the resiliency of a scale-out architecture like Elasticsearch, where you may see intermittent issues where other systems may have failed outright. So if you're starting to see a backlog, if you're starting to see delays, that's not okay. That's something that you should start to address, because it really, I've seen scales where you can take in hundreds of thousands of events a second. There's probably not going to be a situation, especially on the middle and smaller side, where that should really be the case for you. I think the largest one I worked on recently was something like 290 billion records, and the customer was able to visualize them all within 20 seconds, which 20 seconds is a long time for Elasticsearch, but we're dealing with nearly 300 billion records all being presented in that time span, and there are very few systems that could achieve that. So I think a lot of this is just going to be know what the patterns are of your system, recognize when you're outside of those patterns, and if you are seeing delays, if you're seeing errors, it's time to address those issues. And when you're behind on a major version, that's when you should be planning, because we will support version 8. We're on version 9. 8 is still supported, but it should be time to start making your way to version 9. And then when version 10 comes out, same kind of path.
I guess, yeah, that's very, I've also seen similar sort of situations in multiple clients. So I guess, yeah, once I guess it just boils down to first really understanding what do you want, what your data is like, and, what are the outcomes that you are expecting.
Absolutely.
Next, I would like to understand, where have you seen people, struggle with adoption of Elastic Stack? Because the way I see is Elastic Stack is a sort of, Swiss knife for a lot of enterprises. You can take care of observability, you can take care of search, you can take care of security, but still there are a few gaps where, people have not adopted it as much. What are the key reasons that you see that, people have not, or struggled with this adoption of Elastic?
So I think a lot of it is just mindshare, and I think part of it is being the victim of the success of, I guess, being known as Elk, where this was the primary logging platform in the last maybe 10 or so years. And the number of conversations I've had with both implementers and executives that go, I didn't know you did that. And so that's on us. I think that we could do better on the I didn't know you did that discussions, but we're a vector database. We do security. We have an endpoint antivirus that is one of the top 3 endpoint antiviruses in many of the tests that are being run right now. And people don't realize the sphere of where we operate. So if you're doing something with Gen AI, if you're doing something with observability or security, the other thing is not understanding how we operate when it comes to how it's sold. Like, we don't have 50 different SKUs and you must buy this. Oh, you don't have that feature. We basically, as of right now, have Platinum and Enterprise for the most part. And if you want to use it for search, if you want to use it for observability and security, those are all already there.
Got it. All right, this was about the adoption, but next I want to talk about the set of audience who have been using Elastic Stack for a while, but they have not been following best practices, or they are struggling on the day-to-day operations of their Elastic Stack. And now they are thinking, okay, this is a good tool. It's just the implementation journey that has been, one wrong step, then wrong step. So it becomes a mess. So once they are on their optimizing journey, what are the priorities where teams should start looking, like infrastructure or indexing strategy, shard strategy, query optimization? Where should they start, the optimal optimization journey?
Okay. There's a couple of things, and that's a really good question. I think sometimes, especially if you're starting out, I would say don't optimize early. That will often get you into a loop of, I'm trying to build the best thing, so I haven't started building anything. But in the situation where you're describing this, if there's already an existing platform and you're starting to see that maybe there are things that are not ideal, I tend to, being a former infrastructure person, that's where I tend to start. I will say, does the equipment that I'm using meet the needs as both the non-functional and the functional requirements for what I'm trying to achieve? And I don't usually optimize queries unless I start seeing that there are performance gaps in them. But that's really a lot of this is we can instrument, and you should instrument, observability on your tools, even if it's an observability tool. You need to know what it's doing, how it's behaving, and what normal looks like for you. And then you can start to see, I've seen really bad queries where you've optimized a query where it's like it takes 14 seconds, you change it, now it's 39 milliseconds. And that's a gigantic difference because you need to learn about some of these things. And we have free training, and you can reach out again to one of our partners like yourself or to Elastic, and we can help you optimize that. We're not going to charge you money to do just a basic consultation on like what's going on. But ultimately, that's where some of the tools around, I know that there are people who are using the free and basic, but I've had discussions around how sometimes the paid for versions are actually so much better at what you're doing that you can save money on the infrastructure cost.
Got it.
So yeah, it comes down to really where the gaps are in there. There's not really a one size fits all. But ultimately, we have diagnostic tools that we can use. I'm actually writing tools to help analyze diagnostic tools within Elastic. those are good places to start. Understanding the APIs, understanding the behavior, and not worrying about I didn't do it right. Nothing is written in stone, it's written in YAML.
That's just really insightful. I can think about my early days of Elastic, and I did not have all of this knowledge. So I used to scratch my head a lot, going through each and everything. But what you described is, I guess, the best strategy. Instead of thinking what went wrong, if you just try to understand the pieces, you will figure it out,
Yeah,
and it all makes sense. Thank you.
no worries.
And then talking specifically about the shard strategy, right? So we have different use cases, right? We have observability, we have search, and then we have security. People usually get confused between sharding strategy. They often take some of the basic principles from a typical SQL database. Okay, this is the sharding strategy that I used in my previous company, or at a previous employer, but they were using a Postgres or a SQL base. What is the most misunderstood thing associated with Elastic in terms of sharding strategy when it's set to a big scale?
That's actually a really good question as well. I think one I come into a lot is people not understanding what a replica is, where they believe that replicas are only there for resiliency, but replicas are also there for the ability to query. So they're a full shard. They still need to be written to, they still can be read from. And also, it's, I think, partly sometimes when you're dealing with search use cases, it's understanding that there is a latency trade-off of having more replicas. You get more throughput with replicas, but because each replica exists on a different node and will have its own cache, then sometimes you increase the latency to improve the throughput. Additionally, one of the other things I've seen is we have a default strategy of one shard now. It used to be 5 for an index. Not understanding when that does not fit. We're trying to avoid too many shards on a cluster, creating performance bottlenecks. But if you're going to be pushing hundreds of thousands of events per second across dozens and dozens of nodes, you probably want to have more than one primary shard, because each shard is going to have a significant impact on how much throughput you can get into the cluster as well. So I guess that, and maybe a little bit on the index lifecycle management. So I could have an entire session just on shard strategy. I don't want to get us too bogged down, but I think it comes down to just understanding the throughput, latency, and the ingest of what shards provide to you, and sizing. And sometimes people will see articles that were written in 2017 when version 5 was still relatively new, if it was even out, I don't recall. And they're taking what they read in 2017 saying, this is my shard strategy now. I think it's probably better to just have a conversation in where we have what version are we on, what are we trying to achieve, and what's optimal for us. And you can test it out. We have a tool called Rally, which is good for benchmarking. You can use it with your own data sets, or you can use it with an existing track. It may not be perfect for what you're doing, but it'll get you a baseline of what you should be able to get with what you're building.
Got it. And yeah, thank you for mentioning the Rally tool. I guess in your answers are so insightful. You have been giving bits here and there, the diagnostic tools that you mentioned earlier, the diagnostic for the diagnostic dump, and then the ES Rally. This is one of the tools that is not really out there as popularly as it should be, I feel so, within the enterprise Elastic stack skills. And whenever we are doing consulting, we have to bring it up, explain to them, and it becomes a shocker for me. You have been using Elastic for 8 years, and you should probably be using this. So yeah, thank you for bringing that up.
Rally is great. I'm also working in tools for some of the benchmarking as well. They're not ready for prime time yet, but we'll see if that ever happens.
Do you think we can see something similar on the vector side as well? Analyzing the vector performance, taking a deep dive there?
I don't know if Rally would be the best tool for that necessarily, but I know that we have some internal benchmarks. I'm probably not the best person to ask on the vector side, but I do know that we have teams that are benchmarking our performance against our own builds, against some of our top competitors. And when we see discrepancies, we actually dig into it to say, okay, what do we do to optimize so that we are a leader? So we're not just doing this because we want to make the next sale, but we want to be the tool that everyone says this is the best. And I think that drives sales as opposed to making it a sales and marketing-led culture. We are definitely engineering-led, where we say, what is it we're trying to give our customers, and how do we do it in a way that makes them perform better?
Exactly. And this is the thing I love really about Elastic. Even at this scale, it is so agile. It is pushing out new upgrades. Even with vector performance, if you see introducing BBQ, and then disk BBQ, and then consistently increasing the performance and benchmarks, hitting the benchmarks, I think that's the best thing for me about Elastic.
Absolutely. And I mean, I know I haven't gotten on this topic just yet, but one of the other things that we've done with our inference services, we acquired a company called Gina AI. So now
Mhm.
we actually have some state-of-the-art models that will actually do multilingual inferencing for you. And that's going to be what we're looking to do moving forward is we're not just a data store. We're not just a place you stick your logs. This is something that you can start. Our goal is how can we make our users feel free to use natural language to get answers? And I think that's going to see a lot of benefits to both us and to our users in the coming year or so.
All right. All right. With the next question, I want to bring us back to the root of the cluster performance.
Yep.
So what are some of the signals or KPIs that will tell you that the cluster has outgrown its current architecture? Like the software side and the configuration side, we are good, but the infrastructure and the workload side has outgrown. Now, what are the signals that we should look into in such a situation?
So it's going to depend a lot on if you're actually monitoring your cluster or if you're listening to your users as that kind of canary in the coal mine. If you're monitoring your cluster, you're going to see things like gaps in the data on the monitoring side. You will probably see things in the logs like there were 429 response codes showing that there was a back off and retry event in Elasticsearch. But ultimately, it's going to just be the performance is not going to be what you expect. Or if it is what you expect, maybe you don't realize what you're leaving on the table. So a lot of this is going to come down to errors, long garbage collections, and sometimes if it gets really bad, you'll see nodes that will possibly even leave the cluster because they're so overloaded. The cluster tends to survive it. It's just you tend to see degradations and data moves around and it's not optimal.
Exactly. And the teams who are using them day to day, they would not be able to notice, but over the sides, it really outgrows. All right.
Agreed. I mean, disk watermarks tend to be another one that you should look for, especially if you're looking at seeing if you're out of storage space, because when you're out of storage space, things go read-only. And now if you're especially trying to do time series data, that can be quite upsetting to people who are expecting that data landed.
Exactly. All right. I'll take a deep dive into the performance optimizations. And then
Mhm.
next, I would like to understand, what are the biggest hidden performance bottlenecks, that are usually come up in real life or production deployments?
So a lot of this is actually going to be not even on the Elasticsearch side, but on the getting data in, especially when people are using a programmatic, like a tool to say, I'm going to send Python to Elasticsearch or I'm going to send Java to Elasticsearch. They may be using the wrong endpoint API. I've seen people use the right API instead of the bulk API. So you're sending one message with all the overhead that you would be able to send hundreds of messages. Or if you're using Elastic Agent or OpenTelemetry Collector or something like that, then for the number of shards, working back to the shard strategy discussion that we had, you could be sending a payload that sends very, very small writes to your shards, which is definitely not going to get you the performance that you're looking for. You want to send a significant amount per shard, and that will help. Additionally, it's also, we're starting to see that storage speed is becoming more and more important, and also the number of CPU cores. I don't tend to have people have problems necessarily unless they're at a very gigantic scale with whether it's the 14th generation CPU or the 15th generation CPU. That's helpful, but it's not as iconically performing badly as when you have people who are doing things like, I'm still using spinning disks, or if they're using network file storage, you need to make sure that that is optimized very, very heavily for small, consistent writes and heavy EPSICs. So those tend to be the things where you start to see architectural bottlenecks that can cause an implementation to take a lot longer to get from start phase to active users.
Got it. I guess, this conversation is pure gold. And this particular answer, you covered all the tick marks, like you talked about the desk, the physical hardware, software, and
Yeah.
everything. Yeah, thank you.
No
Uh,
worries. I mean, one additional one is this is one that's going to catch a lot of problems, especially if you're on more recent versions of Java. Don't make your heap sizes 32 gigs or larger unless you absolutely know what you're doing. You actually will oftentimes get outside of what is called compressed object pointers. And that means that each piece of memory that you're using is going to be, the minimum size will be larger. So you actually have less addressable space in the heap. So that's one quick, easy one is most times we recommend set it to 31 or 31 and a half gigs, not 32, 33, 34. Sorry, go ahead.
Got it. Yeah. Next, I want to touch a little bit about index mapping. This is something that has consistently come up as issues in clusters who have been running for long. So how should teams think about their index mapping design and prevent long-term performance issues? And one thing that I've seen is when people, they are adopting Elastic, they take, a certain mapping or, indexing strategy, but the use case, the data, everything changes over the time, and they still keep using the same strategy. So how should the teams who are planning to use Elastic for a long time, how should they think about their mapping designs?
That's another great question. A couple of things. One of them is most people, when they start out, they'll use dynamic mappings because they're not always sure about their data, which kind of gets to that first question you asked me about understanding your data. But once you do get an idea of what that looks like, it does help, especially when you can optimize for storage and speed and performance, to say, what are my fields and what data type should my field be? Sometimes that's not going to be the implementer. That may be a developer who's going to have that discussion. But understanding, do I need to have a long or can I use a short? That could use a little bit less memory and a little bit less disk. If you know what a text field needs versus a keyword field, that can also help. So that's part of it. The other one is you don't want to have what's called a mapping explosion, where you have thousands and thousands of fields in a mapping. Sometimes that has the potential to have a discussion of, is this data really relevant together? Should this be its own index? And if it should be its own index, then you can do things to keep that mapping under control. Sometimes we're not even the best actors ourselves. I know in some of our monitoring indices, we sometimes have thousands of fields, so that's not the best. But it just kind of shows you the resiliency of this. It's an optimization tactic and it's a performance tactic, but it doesn't mean it's written in stone. We have the ability to have customers override these settings. It just gives you an idea of understanding what the fields are, what they're going to be used for. Are we going to do math or sort these, or are these going to be interpreted in various types of ways, like different languages and text, or is this really just a keyword?
Got it. Have you ever had an opportunity where you saw that the team there's a issue of mapping explosion? There are a bunch of hundreds and thousands of fields, and the teams are not actively using it. How do you convince the team to make changes to such a thing? Because usually the customer they do not want to let go of any single data, irrespective of what it is and what the use case is. So how should we convince the team? How can we talk them about this implications of having this mapping explosion issue?
Well, you can show the performance benefits. You can have them re-index that data into a separate index and then perform a test against them and see what those things look like when it's actually validated. But another thing they can do is they can retain that data, just not keep it indexed. So it's available, it's just not easily searchable, but they can still pull that data back if they need to. Another thing, and I don't think we've gotten on this topic yet, is we've introduced a mode called logsdb. It's mostly for logs data, but what it allows you to do is, if you've ever seen the inside of a document in Elasticsearch, that's the equivalent to, I guess, a file or whatever you'd kind of look at it. It's like people say, where are my logs? It's not your logs, they're now documents. We used to have a underscore source field that was the original document. And now we have the ability to create a synthetic source field that substantially improves the amount of storage that you need. I like to tell people it's between about 30 and 50, sometimes as high as 60 or 65% storage savings with minimal CPU overhead. Data is getting harder and harder to find space for, and costs are rising. Storage doesn't grow on trees. It's one of those ways that we can save additional costs for people without creating any significant impact on their performance.
Got it. Okay, yeah, that's a very good answer. Before we jump on to the next topic, one final question to, a sort of umbrella question for the performance related issues. What are the signs that the cluster has now become less efficient over the time? It hasn't failed yet. It is doing its job. What is expected is being delivered, but it is not as efficient. And what it results is in the users, they get a bit bad taste of Elastic. Okay, this is slow. I'm facing this issue. It's not failing. They are getting what they want, but it's not at its peak. What are some of this, the parameters which we can look at to identify such clusters?
Well, there's an API called, I believe it is a thread pool. And you can look at a thread pool, see how many things are queued, how many things are rejected. And this is actually one of the things I look for when I do process our diagnostics. And there's also hot threads. You can look at the hot threads. That's a little bit harder because you really want to sort them by the top CPU amounts. And you can usually see things like there are stacking merges or there are a lot of searches that are constantly at 100%. And normally it's going to be just in the latency of how long it takes for certain requests to come back. You can also enable something we have called slow logs. And slow logs you can set to a parameterized amount to say how many milliseconds should it warn on or create other entries in these logs for. There is always going to be a tiny cost in performance to measure the cost. But ultimately, you can see which queries are taking the longest and how often you're seeing queries that are taking an excess amount of time. And that can start to give you an indication that maybe this cluster is underperforming.
So the conversation so far was more towards the engineering and the technical side of the Elastic users. Moving forward, we want to take a different approach. I want to understand from the business perspective, right? Because Elastic stacks in any enterprise is something that touches almost all the departments and functions, the business functions, the engineering functions, and all of those things. So next, I want to talk about, some of the biggest or, the hidden costs that are associated with Elastic environments. And the reason I'm asking this is because, like I mentioned, Elastic usually users are long-term users. And just like performance, even on the cost terms, people keep making changes and the cost at, let's say, 4 years or 5 years down the line gets out of the budget or the intended use case. What are some of the drivers that, that push the cost up?
So I think a lot of this is the architectural decisions that are being made. For example, I think that we may have discussing this a little bit later, but we have a tiering strategy. And one of the things I see people do is they don't follow along, and I'll blame ourselves at Elastic for some of the naming conventions of like hot, warm, cold. And people think that if it's not hot, it's not accessible, or it's just going to be too slow for my users. So they'll keep things hot for maybe 2 or 3 years. The cluster has now grown exponentially. You may have started with 9 nodes, and now you may have 64 nodes. And suddenly you're saying, this is a significant part of my budget. And that's where what I said earlier about how sometimes enterprise can be cheaper than free, rather than paying some of these cloud costs or some of these infrastructure costs, I'm seeing more people go to things like hot frozen. They're bypassing warmth. They don't even use cold. Frozen uses snapshots. And the snapshots are things you should be taking for your ability to recover anyway. With a couple of nodes, or I'll say a couple, it could be dozens of nodes depending on how big the scale is, but fewer than the number of hot nodes, a fraction of the cost. And the performance is still oftentimes way, way, way into the acceptable range. I'm talking about like maybe 2 dozen seconds for a query that goes back 3 or 4 years. And that way, instead of having that 9-node cluster become a 64-node cluster, that 9-node cluster could end up becoming a 12 or a 13-node cluster, and your costs are really outpacing what you're seeing in other tools.
Yeah, I guess, I have seen use cases where the wrong ILM strategy and they are, primarily just using hot nodes and, costs are up and they are unsure, like where to put the data, how to handle the compliance because banks or, the financial institutions, they have certain compliance that they have to make, but they are not using the right set of tools.
Of course. And when you're in a regulated industry that says you must keep data for a certain amount of time, that doesn't always mean hot. I worked in an aerospace company where one of the strategies was we could recover from snapshots, but the ability to not have to worry about where that data is, I just query it. This is not a rehydration. This is not I must go find it. I just query it, and it selects it based on finding it within the query. The query was to go ahead and hit a specific field in anything, it'll return it right from frozen. Like I said, it could be instead of 50 milliseconds or 100 milliseconds, it might be 10, 15 seconds. But most people are pretty much okay with that if they're going back 3, 4, 5 years.
Next, I want to touch upon, how to balance between the cost and performance without over provisioning. So business, the decision makers who are, working and deciding, if Elastic is making sense for them or not, those conversation, what are the parameters that they should consider for performance versus the cost and, without over provisioning?
Great question. So one of the things is, I think sometimes, and I'm going to take your question a little bit on its side, the total cost of ownership, the total benefit of ownership is not weighed as much as the initial upfront cost. Sometimes where you have an outage, for example, that costs you $50,000 an hour, well, if you saved $30,000 in infrastructure and you're down for 2 hours, you didn't make the right decision. Or if you're talking about how you can enable your users to find data more efficiently with a search or a search Gen AI use case, and you're now taking 100 employees and making them 3 times more effective, an additional line item in your budget that's a fraction of that makes sense. So it comes down to where the costs are and how you can kind of take a bigger picture look at the problem as opposed to just its on costs. And I know it's easy for me being on the go-to-market side of Elastic saying just buy more. That's not really what I'm saying. It's just understanding what the impact is to your business, to like what is the cost of being wrong? What is the cost of being slow? And factor those into the total cost of ownership and say the right tool will sometimes be a better thing to do.
I guess, yeah, this is a very good and, fresh view of looking at TCOs, total cost of ownership. Just you don't have to, look at what you are spending, but you also have to look at what is at stake if you don't pay up this cost. I think that's a
Yeah,
really fresh way of looking at it. Yeah.
yeah, and it's not even total cost of ownership. I think it's total benefit and total value, because the cost of ownership really only reflects the cost of like the running of it and the amount of spend on it for that. Other times you have these almost intangible benefits that I've seen people migrate off of Elastic and then they go, I didn't know that, now I can't do that. Or we really miss having this feature and now it's taking us 3 times longer to do case analysis, and I really dislike that. So we end up having a conversation with them 6 months later as they go, well, we were a customer, we'd like to be a customer again.
Yeah, I have certainly seen those two use cases as well. People
Yeah.
would want to come back, if they don't plan it properly. Next, I want to touch upon vertical scaling versus horizontal scaling. What are your thoughts on it, and how should, teams who are using Elastic should look at it? What are the parameters that they should look before considering either of them?
Okay, so I will start by saying Elastic was, I think, originally designed to be horizontal scaling. That being said, there's also a point to understand that sometimes it depends on whether this is a problem with your disk performance, your memory performance, or the number of CPUs. Like some of the internal tools that we have will talk about ingest based on how many CPUs you have per hot node. Now, ultimately, if you have 512 CPUs, you're not going to get the same benefit as having, say, 5 machines with 64 CPUs. That might actually be better for your workload. So the costs of going up, if you're talking about, some people are doing Elasticsearch at very small scale, containers with maybe 2 CPUs, 2 gigs of memory, and they go, should I go with 5 more of those? Well, probably not. You may want to go up to a larger implementation. So it's going to depend on where your bottlenecks are, and start out by saying, like, I would say if you're doing an enterprise level or even a business imperative level deployment, don't do a single node. And don't do 2 nodes. 2 nodes, in my opinion, is worse than 1 node, because if either of them go down, you'll lose the cluster. Start with 3, scale out or scale up depending on size. And eventually, I mean, it's one of those, even if you're wrong, you're usually not very wrong, and it's all recoverable. So even in situations where you're doing this with Terraform or Kubernetes, the opportunity to fix the problem will almost always exist. So I guess the answer is it's going to depend. I know that's kind of a joke within Elastic, it depends, but in this case, it really does. If you're talking about smaller implementations, scale up. If you're already pretty big size, scaling up may not help you too much.
Got it. Yeah, that makes sense. I would love to also talk about, in terms of cost of optimization strategies, what are some of the tips and tricks that you can share us from your experience that are often overlooked, even by, enterprise teams or advanced teams? And what usually happens is that, let's say I'm working for a financial client, I'm working on the same cluster for, and same use case for 5 or 6 years. So, having a diverse experience just like you can give us some, the tips and tricks that are used in different industries that can be, generic and applicable for
Yeah,
optimizing costs.
that's great. And I worked with a lot of financial customers. I was actually in that space for a good portion of my time here. And one of them is actually having too many copies of your data. It works really well because it's kind of baked in, but especially with some of these larger financial organizations, they need to have a DR site or a business continuity site or whatever they call it, and they have a primary site, and then they may have some kind of additional tertiary site. And if everything has full replication and they're all now synchronized to one another, you're spending a lot of money on the wiring and the travel of the data transfer costs. You're now spending a substantial amount of money on your storage and compute to do this. Maybe you can say, hey, in the case of an outage, I don't need replicas immediately. I just need continuity. I have snapshots. I have the ability to recover. So instead of 5 or 6 copies of my data, are 3 or 4 copies of my data enough? And that can take hundreds of thousands of dollars off the cost. Additionally, it comes down to whether you want to do segmented workloads and say, A side is the DR site for B, B is the DR site for A, and you can bifurcate some of that and use things like DNS round robin or some kind of a load balancer and accept what your absolute needs are versus saying, I need everything available at all times. Like maybe you don't need 3-month-old monitoring data of your cluster in your DR site, and that could save cost too.
Got it. I guess, yeah, what you mentioned, not just look at the cost as a whole, but try to look at your auxiliary costs as well, like wiring and everything. You are
Absolutely.
not spending for extra storage, but you're also paying a lot for data transfers. So look at
Yes,
the auxiliary costs as well. Yeah,
absolutely.
got it. Next, I want to, talk a bit about once the clusters have been optimized for performance and cost, what should be the, next ways and strategies path to, make them optimized for a long term. So I would love to understand, how the advanced teams, the more optimized teams monitor Elastic itself, because it is also, just an application and that needs constant monitoring, how it is performing. Are there any bottlenecks that are coming up?
Yeah. So, I mean, we actually have two things that we can do for you. One of them is a monitoring cluster where Elasticsearch knows how to send its own monitoring telemetry to another cluster or to itself. I don't recommend at scale to do it to itself because one, the pressure of that can actually cause more problems when you're in a bind. It's almost like it's a snake eating itself where the pressure of the monitoring is now pushing this thing over the edge. And now if that cluster is unavailable, you don't have access to some of that telemetry that can help you troubleshoot it. So that's one thing. The other one is we actually also acquired a company called Opster, and we've made it available in our cloud and now to our self-managed customers is AutoOps. AutoOps is a tool that allows you to connect in. It collects only just base telemetry of your clusters, not taking your data or anything. And it can find things like your search strategies are not optimal. You have poorly configured ILM. You have other issues that it can help you to try and fix. So that's another thing that you can do to kind of get around some of these problems and tribulations that some people will run into. So that's a couple of things that you can do to help out.
All right. Yeah. Uh, and now I really want to, take, pick up your brain because the insights are like really useful. Next question I want to understand, for people or audience who have a good and high performance cluster, it's cost optimized, performance optimized, what are the signs that they should look for now, which can give them a sign, okay, there can be a scaling or stability issues in the future?
So it's going to be hard to tell. It's understanding the workload. Like, for example, if you're looking in our monitoring data, you want to see a good sawtooth pattern for garbage collection. When you're seeing things start to flatten out, that means that the system is probably either underutilized or it's overutilized and it's in garbage collection too frequently. Additionally, one of the other strategies I didn't really touch on in that last question is understanding and being comfortable with being able to upgrade. So I know you have a tool that helps people do the upgrades. And in general, I would say staying on a current version will help. It will prevent you from being exposed for long-term CVEs as those get discovered. It will make sure that as we optimize pieces of the underlying Lucene libraries, you're aware of that and you have those optimizations. But also, when you understand your use case, sometimes there are regressions that come in certain versions, and I like people to have a lab or a staging environment or some lower environment to test in before you just click the upgrade button and say, good luck, everybody. This is what we're going to do now. I'm of the strategy that says when a new version comes out, put it into your lowest environment, test it for a week or two. If you don't break it, start handing it to some of your users in a lower test environment, see if they can break it, and then stage it that way so that maybe every few months you're on the latest version, not necessarily on the latest version the day after it comes out.
Got it. Yeah, that's a really good strategy. And it can give very real performance parameters to our audience.
Yeah, I mean, when we're talking about logsdb, one of the things is it did increase CPU utilization for a little bit, but within 2 minor versions, we've actually improved some of the other performance profiles, so it's practically invisible now. So if you turned it on immediately, you might have seen a small dip in performance, but if you upgraded like 2 months later, it would have just been flat.
Next, I want to touch upon an issue which very frequently comes up with, big scale clusters is alert fatigue, having a lot of positive falses. And and they are still catching the issues, right? So how should
Yeah.
teams design their alerts and alerting strategy while still catching like the real issues?
This one is near and dear to my heart. I used to be the manager of an SRE team, and alert fatigue was a gigantic problem. So there's a couple of things that you can do. Starting from whether or not you want to and probably should implement SLOs. SLOs can help you with understanding whether or not the alert is actually impacting the availability that you've promised to your users. But additionally, you can do things like you can have alerts that get caught and create other alerts. So when you have an alert, that can trigger an action that then takes a second to say, is this impacting anything else? Has this occurred numerous times? Like you could create an index event and only say, when this has happened 3 cycles in a row, now I want to bring a human being involved. But we've also acquired a company called Keep, which is an AI ops company, and that's being incorporated into Elasticsearch and the stack as workflows. So you have, I know there's a lot of external tools people can use, but built into the product now, we have AI agents that can help you to do troubleshooting, that can pull in knowledge bases about past events and help you write RCAs. But they can also then now start to take actions against various pieces of both your stack and outside of your stack. So you can have it send an email, you can have it perform an action through a webhook. There's a lot of different things you can do to avoid having to wake that person up in the middle of the night. The other one I like to use is, if you haven't talked about it in Elasticsearch, look up machine learning. You can create a machine learning job that will look for anomalies, and that will help you also in some of those things you asked earlier about, like, how do I know when things are starting to get bad? Whether it's on Elasticsearch or your apps or anything that you're looking to do, the machine learning jobs will start to detect anomalies and start giving you actionable alerts when things are outside of normal. Sometimes it'll be low, sometimes it'll be high. You might get false positives, but as they train on your data, they become more and more useful to you. And I'm a big fan of, instead of setting a discrete alert, when possible, set a machine learning job that can create an alert and says, I don't care if, my latency threshold is not 400 milliseconds. When I'm 15 or 20% outside of normal, that's when I should have an alert. And it can be normal for that time period. Like if Thursdays are your busy day, 400 milliseconds may not be good. If Saturdays are your not busy day, I don't really care if it's 200 milliseconds or whatever it is. It needs to be appropriate for what the users are experiencing.
Yeah, this is really, a great insight from your experience. And it can also correlate to, if you are facing alert fatigue, you are actually spending a lot. You are spending on people who are responding to it. You are spending on the unnecessary infrastructure, messaging services, and all of those things. So this also comes down to cost optimizations as well. If you're using
absolutely. Absolutely. And you also end up with burnout. I mean, right now in the marketplace, people are probably going to be more apt to stay at a job, even if they're burning out, because there's not as many of them right now. But if that should change, you may have to retrain people, and that costs money. You may need to hire people, and that costs money. So alerts should be, is this actionable by a human being, and does this need to be done right now?
Something that you just talked about, using ML for alerts to the audience, right? I personally feel there are so many features, within Elastic Stack that usually do not get as much attention. So one question in terms of whole technical framework for all the technical managers, today, if they're listening to this conversation, what are the 5-step optimization audit that you would recommend that they should do, this week on their cluster?
See, that I would say start by getting a diagnostic and maybe talking to your account teams if you have them. That'll be a good first step. But I mean, machine learning is a paid for feature. It is definitely useful. I would say it might be useful to get a trial either on cloud or download a trial key and use it for 30 days, not on your production cluster, but just to play with it. And you can do machine learning jobs across data sets, and you can find those, they're like needles in haystacks. Things that may have been plaguing you, the ghosts in your system that you haven't figured out, and it's usually pretty good at starting to surface those things very, very quickly. We've done proofs of concept with certain customers that they didn't realize that like 3 to 4% of their transactions were failing, and it cost them millions of dollars a year, and they just didn't even know about it. So it's one of those, well, look, if you buy this and you implement this, it'll pay for itself within a year. And they were very, very happy to hear that.
Yeah. It's a win-win on all the fronts. Yeah. Moving forward, we have this one section. We would love to do a rapid fire. Well, I'll just ask the question and then you pop the first thing that comes to mind. So first thing is biggest myth about running Elastic at scale.
The biggest myth, I think, is that it's very complicated and it's going to be expensive and you need a lot of people to do it. And it's getting so much better now with like Terraform operators and various other things that you can just build a cluster very quickly. So there's definitely a learning curve to it, but I think most tools have that.
Right. And today Mark has given us a lot of insights and tools to bust this myth. So try it out them yourself. Next question. One advanced feature that experience, users still underutilize.
I will go back to machine learning. I think machine learning is one of those tools that once you start using that and you start using things like the knowledge base, and I will put a short plug into this, an enterprise key, and you have data in, say, ServiceNow or in Jira or somewhere, or SharePoint, the ability to ask it questions about your own data is very helpful. But additionally, you can actually connect to an LLM, you can install the Elastic knowledge base of itself, and you can ask questions about Elasticsearch and Kibana and Logstash and all things about how to write queries in the tool itself. So you don't need to go look things up as much. Elastic can actually start answering questions about Elastic.
One mistake that CTOs make when budgeting for Elastic.
They don't often bring in professional services. I think that sometimes when we try and say, look, this isn't that difficult, it's true. But if you're not used to doing it and you have people who have not been trained on it, the initial mistakes, while they are fixable, can delay you. They can create costly overruns later. Professional services, in my opinion, are like car insurance. It sounds like you don't want it until you absolutely need it, and then you're going to regret not having it.
Yeah. Okay. Final question. If you joined a company tomorrow, which is running Elastic purely, what's the first thing that you would want to fix?
I'd probably want to fix the version. Most companies are still using older versions. They're very happy with them. We often compete with ourselves in the past because of that. But I would probably start with understanding what version it is and how clean the data is, and maybe start running diagnostics on my own to kind of get an understanding. But it's really going to depend on what they're doing with it.
All right. That sums up our session. Thank you so much, Mark. This insights that you have given up is top notch. Even for me, I had to learn a lot of things, and the perspective that you shared on cost, performance, teams using it, it is fantastic. Thank you so much. It was really wonderful, and I'm sure this conversation will be a guiding light to a lot of Elastic users. Thank you so much.
Thank you.
It was an absolute pleasure talking to you.
You as well. Thank you. Have a great day.
If we have any questions, Floy, from the audience, we can take them now.
I think that I see one, and it was asking about whether or not there's an alert gateway in Kibana. The unfortunate answer to that is I don't know that answer, because I know that there are some significant efforts being done right now to optimize and to help modernize Kibana. Perhaps modernize isn't the term they'd want me to use. So it's something that can always be added as an enhancement request if that's something that you're trying to do. I don't understand necessarily what the alert gateway would be used for. There are probably ways around that. So I'd say maybe reach out to your account team and see if there's something that they can do. If there's maybe a reason for that question, that may not be the right answer, but there may be a different way to do it.
Got it. And I guess, what Mark also mentioned, instead of, just going and creating alerts or using out of the box alerts, you can also consider using ML-based alerts. This is something which is very underutilized, and it not just solves the question that you're asking, it also helps on the cost performance, the inputs that you're facing, the efforts that are being run, made to run the Elastic at scale.
Yeah. And it also has a predictive feature. I will caution saying, look, it's not a crystal ball, it's not perfect, but you can often find out things like when you're monitoring an application with machine learning across the data sets in Elasticsearch, when will I run out of CPU? When will I run out of memory? When will I run out of disk? And it can predict within reason, say, hey, look, we're almost to April. If you got an alert tomorrow that says you're not going to have enough CPU to run this application at the scale based on your growth by April 9th, wouldn't that be better than to find out April 9th, sub-zero outage, everyone on a call, get on the bridge, what's wrong? I think so.
Got it, yeah. I guess that answers your questions. I guess, yeah, that sums up this session. We don't have any other question because you have already explained a lot of things very clearly from technical, from business, from optimization perspective. So yeah, thank you so much.
Thank you for having me. Everyone have a great day.
You too. Bye-bye.